These ones? Oops.
It's there.
All right, that'll be that. Cool. Well, I think there's a delay anyway with the thing, but so my name's James, or Flux. I am one of the guys in the crew here helping Wolf start the SDR meetup. Mainly I'm into typing, hacking, hardware, radio stuff. I moved to Sydney about 6 months ago. I work as a penetration tester. And this talk is about me building a hardware Dropbox with my HackRF. But why am I actually making it in the first place? So let me see if you can. Whatever. So I want to capture radio signals. It's awesome. Probably the best way to do that would be from my roof. Unfortunately, I can't really get to my roof, which is not the best, but there's always a silver lining, I think. There's plenty of nice roofs around. So the idea is essentially to make a device that I can, over the internet, access my HackRF. So there are already ways to do this that people pretty widely do to access a HackRF over a LAN. And I thought it might not be that hard to do it over the internet. So this was what I decided to build. And it's pretty much based off how I would design implants for red teaming when I do that as well. So the slides aren't catching up, but that's fine. We've got a picture here. So essentially, it's a HackRF inside a box. Any SDR would work, connected to a single board computer, in this case, a Raspberry Pi. And I'm using a 4G dongle to connect to the internet. Now, I know probably there's already a lot of you that are thinking this is suboptimal, and I completely agree with you on all counts. But this is me just wanting to build some stuff and test it. There are some other things I plan to put in the design as well. Solar panel to charge the battery. You can see it's going to connect over the internet via the 4G dongle to my house, and I don't even have to go outside anymore. There's a couple of requirements for the design. I don't want to spend a lot of money, so it's going to be cheap. I want to make it waterproof. Ideally, it would have 24/7 operation. And I want to essentially have local access to my HackRF or SDR. What I mean by that is essentially as if it was plugged into my own computer. That's what I want, but I want it in this device. So I thought this would be pretty achievable. Also didn't really want to degrade SDR performance that much. And so you've already seen this is what I built, but essentially it's a HackRF Raspberry Pi. The dongle there is a Huawei 4G dongle, and I'm using at the moment a 15,000 milliamp hour battery to charge it. Now, there's a whole bunch of concerns with this right off the bat. So in this case, these sort of batteries here, they can't generally just charge and discharge at the same time. So you can't use something like this generally with a solar array and then power it over USB, and it just doesn't really work like that. You'd have to actually build a dedicated charging circuit and things like that. That's part of a future planned project. This is more of a proof of concept, see if it can work, see how much power it uses, that sort of thing. I also wanted to check if there was actually enough room to put everything in a box. I was a little bit worried about, you can probably see it here. So the USB ports here on the Raspberry Pi, the maximum current they can source is 1,200 milliamps. And the HackRF uses at maximum about 500 milliamps. And these USB dongles for radio, or for 4G, they can be highly variable in how much current they use. So again, testing was the best way to do it. So this is one of the reasons why I built this prototype. One of the other things that's really, really problematic is this box here. I chose a metal box because I was like, it'd be great. I'll put a Faraday cage for my HackRF and it won't get noise from outside sources. And then I'll put a bunch of really noisy stuff in the box with it, like a Raspberry Pi, a battery, USB buses, antenna buses, and most importantly, an actual antenna transmitting inside the box. But whatever. And before I start this part, how many people are familiar with things like SSH port forwarding and stuff like that? I assume a bunch of you are. So that was the main technique I planned to use, but essentially there was a problem I was trying to solve, and this is it. So generally at home, you're going to be behind a NAT firewall. So you'll have an internal IP, and then you'll have some random public internet IP. By the way, you can scan these, I don't care, they're not like my public IPs, I just chose public IPs. So you're going to have an internal IP, but you'll have a public IP as well. Let's say you're connecting out and you want to connect to your Raspberry Pi. You might even know its public IP address. You go initiate that connection, but the services that you want to access, they're not going to be exposed. They're actually behind like a carrier grade NAT generally. This might put all your services here, HTTP, SSH, things like that, behind like an internal network. But there might even be other customers and stuff sharing that same public IP as you. So you don't really know what's in between. But we have a solution for this problem already. This is the best, by the way. So this is essentially the idea of SSH port forwarding. So the idea is that, well, we can't connect directly from, say, my laptop to my Raspberry Pi. It can make connections out to a public internet IP address, and I can make connections out to that same public internet IP address. What if we could use that system to join these connections together? You can. This is how you do it. And so then you can eventually use this connection here that you initially make, and you can connect all the way back through. If people are interested in this, they can talk to me afterwards. I'm assuming that quite a lot of people here know how this sort of stuff works, though. So there are some good and bad things about this.
Question.
Yeah.
So is this a problem just because your 4G dongle changes IP addresses all the time and like shared?
No, so the main reason this is a problem is because it's behind, we'll go back to the earlier picture. It's because it's behind a NAT.
Right.
So those services, you don't control the services that are generally exposed through that public IP when it's a carrier grade NAT. So it's really challenging to find a way to actually access those services themselves. So SSH port forwarding is one way you can choose which of those internal services you expose on the internet.
Right.
So as I was just saying then, one of the awesome things about this technique is it's not just SSH ports that it forwards. You can forward other TCP services, things like a VPN, if you wanted to like connect all the way into that network segment. You could potentially forward a TCP SDR stream, which is one of the things I was interested in. Provides awesome encryption and authentication, well tested. You can automate authentication, so you can essentially run automated scripts against your endpoint. You can get it to connect back automatically. And you can just take control of your Raspberry Pi if you want to capture SDR streams locally. So with the design at the moment, I could already connect in and capture an SDR locally on my Raspberry Pi, then I could copy it across again via SSH to my computer. There are some problems with it though. If you've ever done this before, you'll know this. It can be really unreliable. There are ways to fix that. You can only forward TCP services. So UDP, which is one of the most common ways to access an SDR stream, you can't forward over this. And you kind of need to know in advance what services you're going to forward, or you can create a dynamic proxy to forward them. And it's a bit slower as well. So this is what I personally use for SSH access. It's a
system D for the win.
Yeah, man.
Nice.
I'm not living in the past.
That's quality.
The future. Yeah. So I wrote this as systemd script. I think I've modified it from somewhere probably, but this program, AutoSSH, is a variant of SSH that makes sure, monitors the existing SSH tunnel to make sure that it's still active. And if it can't send data through it, it kills it and reestablishes the connection. So it's really, really good for establishing reliable reverse SSH connections. You can see here as well. So at the moment, I'm forwarding TCP port 2222, oh, sorry, my local port 22, which is SSH, to on the remote host TCP port 2222. And I've commented these out, but these are other ports that may or may not become relevant later in this talk that you can also forward in the exact same script. And here I'm doing it as a user called Sandbox, which I hardened. So, yeah.
So this bit runs on the Pi.
This bit runs on the Pi, correct. And so this establishes a reverse connection out through the NAT to a jump box in the cloud. Could be AWS or something similar. And then I can connect through, if I connect to my jump box, then I can connect locally to port 2222, and I will be out on my Pi. If anyone has any questions at any point, just seriously jump in. This is going to be super quick. I would recommend doing some hardening on your SSH configuration, because if you want to just put this somewhere on the street or on some random roof or something like that, I don't really want people finding it, getting the SSH key off, SSHing into my jump box, causing all manner of mischief, right? So this is the hardening I did. Essentially, this is wrong, by the way. You have to set gateway ports yes to do the reverse SSH connection like I did. But with modern versions of SSH, so they're in Debian testing, I can't remember the exact version, you can do these permit listens, and you can restrict what ports that you can open with a reverse connection. Here I'm restricting it so you can only do those 2 ports that I'm interested in this case. And this is for local port forwarding, which is another type of port forwarding. There's also a command restriction option. You can restrict what commands the SSH tunnel can run. In this case, it will only run echo. I commented that out. It's not my favorite way of doing it. If you use auto SSH, this will actually break it because it'll think that the SSH connection has failed because of the return code of echo. So I just set it to bin true, and that seems to work better.
Are these slides going to be posted somewhere?
Yeah, 100%. That's why I put the code in there, so it's like super easy to follow. All right, cool. So this actually, like that part of it is, I've done that heaps of times. That works really well. That script is like my 5th go at making a reliable reverse SSH connection, and it works pretty well. You can combine it with a cron job and stuff, but yeah, it's pretty good. So we're now looking at ways that we've got this connection working and we can access our Raspberry Pi through 2 NATs. How do we actually control the SDR without just going in there and running commands in the CLI like an animal? So this top one was like my preferred favorite, but I already had concerns with it other that. But USB IP, it seems like a magical sort of program that can provide USB access over TCP, which would be awesome. And it's actually like part of kernel modules now, so you don't even really need to install that much stuff to get it to work. Yeah, and so if you use this, essentially what it would do is it would forward the device all the way through over a TCP tunnel to your computer, and your computer would think, oh, the HackRF has been plugged in. There's also a couple of other options. I looked at SOAPy SDR, which can provide UDP and TCP streams to an SDR device. You may well be using that already, or SDR Angel is another option. And if you know of other ways to access SDR remotely, have a chat. So I tried, this is me trying USB IP. So this is essentially how it works. You list what devices you have locally. So you run these commands here on the Raspberry Pi. You list the devices locally. You choose one of them that you're interested in. This is a USB stick in this case, binds to it. And then on another device, in this case, this might be my computer at home, I have gone through my SSH tunnel. I've forwarded the USB IP port through to my jump block. And you can actually see on this remote host, in this case, it's just localhost, because that's what I forwarded the port to. you can see the flash drive sitting there. This is an example of the command I might have run before that, but this is the wrong order. And then I can attach to it, and when I list USB devices locally, I see the string and the ID that corresponds to the USB device on the remote system. It's pretty cool, but it totally does not work for HackRF, mainly because the HackRF requires a really high-speed USB connection, and I thought this might be a problem right off the bat, but I want to try it anyway. It doesn't even work on a LAN. I think the way I think about this and why it doesn't work is the USB spec has like a maximum distance that you can allow for a USB cable. And TCP as a communication protocol kind of, you don't really know how long it's going to take to send bidirectional traffic. And USB isn't waiting around. It's like, I didn't get this stuff like that you said you were going to send me. So that's how I think about it. Maybe there are other ways to think about it, but it doesn't seem to work for HackRF. You can try it yourself if you want. So, SOAP SDR. How many of you guys use SOAP SDR for communicating with your SDR device? Couple, awesome. So, SOAP SDR has a server daemon that comes with it. It's called SOAP SDR server. And you can start it like this. And that auspicious port was one of the ones I forwarded through my jump box. And you can see here, after doing a suitable reverse SSH port forwarding of port 55312, the one that SOAP SDR listens on. This is me from my computer at home, and I can see my HackRF listening on that port over the internet. Awesome, through 2 NATs. It's totally going to work. Well, that's the wrong way. We'll wait for this, but spoiler alert, it doesn't work. Essentially, what happens, how SOAP SDR server works, is after you go, I want to make a connection to this device. So I can pull all sorts of information off the HackRF and it works fine. But the problem is once you go to establish a connection with a SDR, it then opens up another port, usually UDP, and then it will send data over a string. But that IP that is sitting on is a completely different IP to the one you forwarded port to. It's quite complicated, but essentially, yeah, that port it chooses as well. You can't just forward through SSH because it's dynamically chosen. It's an ephemeral port chosen by the kernel. So you can't really predict it in advance. There's a couple of options. You could write a cron job that looks for ephemeral ports being opened and you could forward them through SSH. I haven't done that yet. Maybe it'll work. I briefly tried patching the source code and it sort of worked, but not well enough to share here. So the long and the short of it is you can access a device like this over a LAN, but as far as I can tell, using SOAP, there's no way to do it through NATs and things like that.
IP tables rule? Like IP tables forwarding rule, maybe?
Potentially, but like...
Just a thought.
Yeah, maybe, I mean, maybe that would work, but like you need to make sure it goes over the... Yeah, you could have a port ready for it locally. Yeah. That might work, yeah. And you could choose the entire ephemeral range and then forward it through your prearranged tunnel port. Yeah, maybe that would work. On the Git for SOAP SDR server, you can see some of the guys in January this year talking about this exact problem. They also mention the lines of the source code that you could potentially look at to change the functionality yourself. They're pretty much saying that, you know, it'd be really nice to be able to access these devices over the internet. We should probably do that. Yeah. So going back to, oh wait, there's one slide in between. SDR Angel, has anyone used it? No, that's what I thought. I haven't used it either. It apparently also does this sort of stuff. Maybe it'd be worth testing, but I haven't done it yet. So let's go back and revisit the original requirements for design. It's sort of cheap. Does anyone know where to buy those like tiny little rubber bands that, like, if you've ever had braces, you use those rubber bands for your teeth? I need some of those to like waterproof this. So if you know where to buy them, then I can make this not orange.
Like an O-ring?
Yeah, exactly.
Aldi has a sale of O-rings. Last time I went to Aldi, they had a whole pack of. I'm like, who's going to buy O-rings?
Well,
Now I know.
I'm in the market for O-rings.
Sell them at hardware stores.
You can 3D print stuff using the right sort of roller and print one that's the right size.
That seems like very much overkill, but I would also love to do that. Like next talk, this is how I 3D printed an O-ring.
Well, Aldi's got a good one for $400 at the moment, 3D printer.
It definitely doesn't have enough charge for 24 hours operation. Like I didn't really do any of the solar stuff. And then some of the other stuff, maybe it'll kind of do, but probably there are going to be significant interference problems as well. Later today, I will have this working and we can see it working over a LAN. Yeah. Are there any questions?
Go ahead.
Can you talk a little bit about the capability of the HackRF product?
Yeah.
And how it compares to the RTL product?
So RTL is kind of like, so it's like a digital TV tuner, and some people found out that it can tune to heaps of other frequencies other than just the TV frequencies it was designed for. But the problem is it's not really well designed for those other frequencies anyway. So it doesn't really get a very reliable response at the entire frequency range. HackRF, and the range is limited that you can actually tune it to as well. HackRF, my understanding, can tune to anything between 0 and 6 gigahertz, but I'm sure someone who knows the exact specs.
Near enough.
Yeah, and it can do some other stuff as well, but mainly it can transmit pretty well as well, but it's pretty low power. You need to use an external amplifier really.
And it's only half duplex.
And it's only half duplex, exactly. So you can't receive and transmit at the same time. So before a lot of the more modern SDRs came out, some people were buying 2 HackRFs, having one in receive mode and one in transmit mode, things like that. It is pretty quick at switching between them. So you can theoretically receive something and go, I need to transmit now to like hack this thing, but yeah. But it is, I guess to answer your question, if you're interested in this and you use your RTL SDR quite a lot, I would 100% buy something like a HackRF because it is really good by comparison.
What kind of potential red team engagements would you see if this being used?
So I guess I probably wasn't very clear. I wouldn't really use this in a red team. I use the single board computer and a 4G dongle in a red team. But so that's kind of like how I knew a lot about the natting and stuff like that. But
so I'm just thinking this would be epic for like on-off keying for a garage remote system.
you just leave it near their garage and just wait till they
that'd
drive
be
home.
great.
With the red team, I might just say that sometimes people transmit the weirdest shit over pages. So you get like safe codes, you get medical history, you get just all sorts of
Change
weird
request
stuff.
codes into data centers.
Yeah, absolutely. So if you were
Had one
doing
of those 5 years
like
ago.
a red team on maybe a hospital or a data center or something, that kind of nature, then this can have a very valid use case for that.
You mean proxy? Like,
Yeah. Any other questions?
what were you thinking about for? It's just a problem that I face as well, specifically broadcast FM interference.
Yep.
So similar problem, but you're looking at a different band. But what are the options there that are kind of available, sort of low cost, like for filtering, like RF? I assume it would be a filter on the outside.
Yeah. Well, in this case, so there's a couple of different problems here. You're talking about interference with the other devices that are sitting in the same.
Oh, sorry. I meant so I got a line and it gets saturated with broadcast FM stuff. It just screws the signal. So I was just wondering about sort of cheap filtering options.
Yeah, I'm not totally across all the different options for inline filtering and stuff like that, but I would probably, if it was me and I was having that specific problem, I would probably just build an active filter with an amplifier and stuff like that.
Right.
Because it's always awesome boosting the signal as well, because some of the internal amplifiers in these devices aren't the best. So,
There's a company called New Elec.
Yep.
They do a $10 FM filter.
Okay. Done.
10.
Thanks.
And they do an AM1 as well.
Oh yeah. Cool.
So SDR.com has a couple of those sort of things as well.
Right. Okay.
They're cheap.
How bad was the interference as far as metal blocks and all that?
So I haven't really tested it that extensively, but I would say that the interference doesn't stop it really connecting or capturing or anything like that. So it seems all right so far, but it's hard to know. So I would like to test it more robustly and then like give you some graphs and stuff like that, showing exactly the differences between interference and not, but I didn't really have time to do that. One thing I didn't mention, sorry, I'll get to your question in a sec, was there was something actually really important about the design that I didn't mention. These Huawei dongles, I've known this from previous jobs, but they have external antenna ports. That's why I chose these specific dongles, so that this is actually a 4G dongle antenna. And I've actually put that through the metal box. If I didn't do that, I wouldn't get reception when I close the lid on this thing, so it wouldn't actually be able to connect out.
Does that particular Huawei dongle work without any config changes on the fly? Is it plug and play? Or have you got a message?
Yeah, so that's a really good question. A bunch of these different dongles don't really work that well at getting IPs automatically. It's kind of like, you have to know. I knew that this model was pretty good, but some of them you can buy up. So
Hey.
oh, right.
But also some of them present as WN0 instead of PTH something or other. Or...
The big problem they have, so on Windows, what these things do is they'll generally present as a mass storage device, and they'll give their drivers to Windows, and then Windows like, I'll install that, and then they'll switch. They're like, I gave the drivers over, now I can switch to a 4G dongle, and they do that on Linux. And Linux, like, I don't need that. Why are you a mass storage device? So you have to kind of like blacklist the. It's quite complicated and it never works. So
which one is that?
It's in the slides, but it's the. Let's go.
Because another model, I think I found an 8372 or something that works out of the box.
It is a E3372.
Yeah.
I think it cost me $30. You have a question?
Yeah, so why didn't you just like, have you considered running SDR itself on the Raspberry Pi? I guess performance of like running Blue Radio or whatever on SDR.
I can definitely do that.
Yeah.
Like, and so I can capture radio traffic now from the CLI and things like that. That's fine. And I have been doing that with this exact, but I kind of want it to not have to do that. I'd like to use GUI applications and stuff on my computer to sort of have a look at the spectrum and that sort of stuff.
Does it become a power problem too? Because obviously you're doing a lot of processing then.
I mean, you're right, the Raspberry Pi isn't well suited to it. You can improve some of these ones, like the model, this is a 3, model B and above, they can actually have 64-bit kernels now, which improves the performance somewhat, but it's still not great doing SDR stuff locally on them. Anyway, I think I might let Baz do some talking. I'll have this demo later and we can all have a look and that sort of stuff.
Thank you.